Alright, so in this video, we're going to be looking at this practice problem, number 3, on the Calculating Average Atomic Mass worksheet. So in this problem, we are told that we have an element of copper that has two different isotopes, and the mass numbers for these isotopes are 63 and 65. Now, if we go on to read the rest of the problem, we notice that the atomic mass of the isotope that has a rounded mass of 63, the exact number is 62.93 AMU. And we know that we have 69.2% of that because of the problem right here. We then know that we have 30.8% of the isotopes that occur have a mass of 64.93. Notice that at the beginning of the problem, we're given two rounded mass numbers, and in the second sentence, we're given the exact numbers. When we perform these calculations, we want to be using the exact numbers that are given. If no exact numbers are given, then you can go ahead and use the rounded numbers that are given instead. So in this case, because we're trying to calculate average atomic mass, we're going to use this formula that's in the yellow box. The amount of A times the mass of A, plus the amount of B times the mass of B, plus the amount of C times the mass of C. Now we want to divide all of that by the total, which in this case is going to be 100% because our problem is dealing with these percentages. So the first thing that we need to do is think about what variables we know from this equation that are given to us in the question. So what I want you to do is take 1 minute to copy this green box down to your worksheet or your interactive notebook, and I want you to fill in all of the information that you know that could go into this green box. So pause the video and fill in that information now. All right, now that you've done that work, you should have filled in information that looks something like this. We have an amount of 69.2 and a mass of 62.93 AMU for A. For B, we have an amount of 30.8 and a mass of 64.93. Now notice that we don't have to worry about this amount and mass of C because in this case we're only given two isotopes. So now that we've done that, you can actually take a minute to just plug all of these numbers into this formula. Take some time to do that now. Pause the video, and when you're done, restart it. All right, so partway through, this is what your equation should look like. You've plugged in the amounts of A and the amount of B. Now that's all that you have to do is plug in the mass of A and the mass of B. And once again, you should have an equation that looks something like this. You've plugged in all of your numbers. The last step, all you have to do is put these numbers into the calculator and solve. Now this part can be tricky. I would do this number times this number, press enter, write that new number down, and then this times this, enter, and write the new number down. Then you're going to divide the entire thing by 100. Try it a couple times in your calculator to make sure that you continue to get the same answer. Once you're ready, you can pause the video to do the practice. Once you're ready, you can start the video again, and I will reveal the solution. All right, so this is the solution that I got. The average atomic mass of copper is going to be 63.546. Now, you can do a quick check. You want to make sure that this number falls between the two mass numbers that you've given. And in this case, this number is slightly above the smaller mass number and slightly below the larger mass number. So logically, this number makes sense. Every time you do one of these questions, make sure that your answer also makes sense.